Hey guys, it's Mr. Calderon with Queen My Pawn. I'll be discussing compound interest today. Now that we've discussed exponential functions, we have a stronger grasp on compound interest. Of course, you don't know what that is yet, but neither did Bernoulli until he himself asked, if I have $1 and I get 100% interest on it after putting it into a bank after 1 year, how much will I have? Well, obviously 100% interest of $1. It's going to be just one more dollar. So he's going to have $2 after 1 year. But let's say that instead he got paid interest halfway through the year. So let's say that he had $1 and the bank paid him half of his account in interest, right? So he's getting paid 100% interest, but halfway through the year. So it's 50% of his account. So that's going to be, 1 plus half of $1. And then he's going to have 1.5 or 1.5. Then the other half, they're going to do the same thing. They're going to pay him whatever he has, which is 1.5, because 1.5 times 1 is 1.5. That's his original balance, plus the half of that, which at that point, it's no longer 50 cents, it's 75 cents, because he has $1.50 right here, and half of that is 75. So it turns out $1.50 plus 75, well, that's 225. Or in other words, 1.5 times 1.5, well, that's 2.25. And Bernoulli saw, oh, that's interesting. My interest went up, and this time by a lot, 25 cents. Relatively speaking, that's a lot of money compared to $2. So Bernoulli asked himself, oh, what if I do it for 3 months? So then you get 1 plus 1 over 3 times 1 plus 1 over 3. Not 3 months, but like 3 times. So that's every 4 months. So every trimester, I guess. And you're going to get some number, right? But this just also equals 1 plus 1 over 3 to the 3. And what's interesting is that these numbers right here are the same. So a general formula for this would be, let's see, how can I move this? There we go. A general formula for this would be 1 plus 1 over n to the n power, where n is the amount of times you're getting paid interest throughout the year. Okay, so if you were to get paid interest daily, you would have 1 plus 1 over 365 to the 365 power. And that's going to give you some number. In fact, let's go ahead and put it in. You can even put it into decimals. You just do 1 plus 1 over 365 to the 365, and you're going to get 2.714. Okay. And if you notice, you can repeat it every second for a whole year. Let's see what happens. That's 86,400. That's how many seconds there are in a day, times 365 days, so that's the whole year. And then 86,400 times 365. Now you're going to probably expect a huge number, right? But it turns out to be 2.718, blah, blah, blah. And in fact, that's the number that's very interesting to Bernoulli when he discovered it. And so Bernoulli was a mathematician in 1600s, the 17th century. So Bernoulli saw this. As n gets bigger and bigger, or in other words, as n goes to infinity, then the function, I'll call this f of n for short, okay? The function of n goes towards one particular number, 2.718. And later, this number was called E after Leonhard Euler. Now, I don't want to digress into why it was called E and not B, even though Bernoulli discovered it first. But this number is super important. It's what you get when you compound continuously. So it's a natural number, but not a natural number. I can't really say that because natural numbers are like 1, 2, 3, etc. But this number occurs in nature. Okay. So let's consider a question first. Okay. So let's see. You can go to google.com, compound interest problems, and let's see how to apply this. Because look, let's drag this up again. Over here, we assume the interest was 100%, right? But if the interest isn't 100%, then this number isn't 1. Like if it was 20%, then this would be 0.2, because 20%, you got to convert that to a decimal by moving the decimal place 2 over here. So you get 0.20, and so it's 0.2. Anyways, we're going to do some examples right now with compound interest. Okay. Let's see. Okay, let's put that in a sticky note over here. Let's make this font bigger. There you go. Connor puts 400 into an account to use for school expenses. So first of all, we're not going to worry about the 400 right now, okay? The account earns 11% interest, so we know that the rate, it's going to be 1 plus 0.11, because 11% converted to a decimal is 0.11. Compounded annually, which means that it only compounds once every year, so we only have to put a 1 there. How much will be in the account after 4 years? Well, after 4 years, you're going to basically just put 4 here. Now, you're wondering, hey, how come you didn't talk about that before? Well, because we assumed that we were only doing this for 1 year, but after a certain amount of years, like let's say you have 7 years, well, that's a hidden parameter, which is t. Okay, t is time, and that only goes right there. You would just basically put that exponent right there. Nothing else changes, okay? So you would put 4. And finally, you got to take care of the 400, right? So you just put 400 right there. Multiply the whole answer by 400 in the end. So let's see what that gives us. 1 plus 0.11 to the 4th power. All right, times 400, 607 and 23 cents. Okay, 607 and 23 cents. Let's see if I rounded it correctly. I did. And when I submit it, it says correct. Of course, it says correct because I'm teaching the subject. Okay. Now this time, Jenny decides to go to the bank. Okay. So thank you, Jenny, for your contribution towards the bank. And this time, I'm going to erase the work here. Jenny opened a savings account, good for Jenny, and deposited 100. We're not going to worry about the 100 right now. We're going to worry about that last. The account earns 7% interest. So just start off with your usual 1 plus 0.07. Compounded quarterly, which means 4 times a year, because there's 4 quarters in a dollar, 4 quarters in a year, blah, blah, blah. The balance after 3 years. So you put 4 as usual. There you go. The formula is complete. Times 3. And the exponent, I mean. And then you put the 100 right here. Okay, great. So in the end, that's going to be a 12, right? We can cross that out. And we can put that in the calculator. 1 plus 0.07 divided by 4 to the 12th power times 100, 123 and 14 cents. This is why I don't like savings accounts. They barely pay you anything. It's like, why even have your money in there? Good work. Yes. Okay, so you get the grasp of it. Compound interest is super easy, but we haven't done one where it's actually continuous interest. So in continuous interest, let's see if they have one. Compounded annually, blah blah blah. Let's see. Let's do compound interest continuously. Continuously compounded interest. So basically, it's going to be the same thing. Let's say that it's compounded continuously, right? In that case, it would be instead of your 1 plus 0.07, this is what you're going to get. I'll show you right now. It's even simpler. It's P times E to the RT. P is the principal, which we always worry about last. R is the interest rate over here at the top. And T is the 7 years. Now, the formula looks different. You can just think of it as PERT. I'm not going to go into how they got the formula. It's a really simple manipulation, but this is a crash course and you're only learning the shortcuts, okay? So it was PERT. You do A equals, again, we don't worry about the 100 for now. We do E to the 0.07 times T, and T is going to be time in years. So you do 0.07 times 3, which is 0.21, and then you multiply by 100. Let's see how much more interest that gives us. 100 times E to the 0.21. $123.36, barely any more money. Or look, this time it's 400 with 9% interest after 4 years. So you just do 0.36 because 0.09 times 4 is 0.36. And then you put 400 there. And the answer is 573.33 cents. And wonderful. Okay, so you understand it now, and it should be straightforward. Again, if you have any questions, you have to put them in the comments so I can help you out. And it can pop up on my YouTube notifications because I'm not a mind reader. So if you like the video, make sure to click the like button, subscribe for more videos, and that way you'll be more educated, and I'll see you on the next one.